Here's a second example, slightly harder, where I'm going to prove that the limit as x approaches 2 of 3x squared minus 2 is equal to 10. And remember, okay, so the first line of the proof is almost always the same. Let epsilon be bigger than 0, because I need to prove it for all epsilon, so let's just fix one. I get to pick my delta to be helpful to me, and I need that this is true. So let's start with here in my scratch work. I need the function minus 2 minus 10 has to be less than epsilon. Oh, that gives me 3x squared minus 12. I want this. 3 times x squared minus 4 is less than epsilon. And the key thing is, what do I know? I know that x minus c, which is x minus 2, is less than delta. So I want to get an x minus 2 in there because I get to control that with the delta. Oh, but this factors. That's x plus 2 times x minus 2 needs to be less than epsilon. And I know that I can make this less than epsilon. So this gives me that this is less than 3 times x plus 2 times delta. But that x plus 2 is a bit of a problem. Well, here's what you do. So looking at this graphically down here with my scratch paper, x plus 2, if you look at a graph of this, my c is equal to 2 up here. So I'm going to look at 2. What happens if I restrict my interval, if I only choose to look between 1 and 3? Well, if that's the case, it's a calculus problem or it's just obvious, x plus 2 is less than or equal to 5. In fact, it's strictly less than 5 on the open interval 1, 3. I'm going to use this to my advantage by saying that, okay, this thing is less than that, which is going to be less than 3 times 5 times delta on 1, 3, which equals 15 delta. And if I want that to be less than epsilon, I can make this delta just needs to be less than epsilon over 15. Now, the question is, how do I restrict it to 1, 3? And it's pretty easy. I'm going to let delta equal to the minimum of, well, notice I picked 1, 3 just because these are 1 apart from each other. So here my delta would be equal to 1 in some sense. You could pick any number you want. You could pick it you want half or 2, but 1's convenient. I'm going to let delta be the smaller of 1 and epsilon over 15. And note that x plus 2 is less than 5 when delta, when x minus 2 is less than 1, which is, right, 1 is, delta's less than 1. So really what I have is this. X minus 2 has got to be less than delta, and it's going to be less than 1. Why is it less than 1? Because delta is the minimum of 1 of that. So I know that this is at most 5. So where does that leave me? That leaves me with, then for all x belonging to domain of f, which again happens to equal r, such that you are within delta of 2, x minus 2 is less than delta. Here's what we get. We know that 3x squared minus 2 minus 10, if all ends up well, I'll make this thing less than epsilon. Right, that's equal to 3x squared minus 12 equals 3 times x squared minus 4. Oh, I can factor this. Equals 3 times x plus 2 and x minus 2. Ah, but look, x plus 2 is less than 5 whenever x minus 2 is less than delta, which is less than 1, which is true. X minus 2 is less than delta. So this is less than 3 times 5 times x minus 2. Oh, and x minus 2 is less than delta. But delta is less than epsilon over 15. So I get 15 times this, which is epsilon over 15 equals epsilon. So in other words, I proved that this is true, and I'm done.